In this mini lecture, I'm going to talk about graphing parabolas. Parabolas come from what we call quadratic functions, if we're graphing a quadratic function. We've talked about quadratic equations. Those were equations that had a squared variable as the highest power variable. A quadratic function, then, we've got a function of this form, y equals something or f of x equals something. We can use either form. And the function has to be able to look like this: ax squared plus bx plus c. So the highest power is 2. That's what makes it quadratic. The a, b, and c are real numbers, so it might just be 7x squared plus 2x plus 3. A, b, and c could also be fractions. In theory, they could be something like the square root of 7 times x squared. But since they're real numbers, they can't involve I. So I couldn't have 2I times x squared or anything weird like that. It's important that a is not 0. If a were 0, it would be 0 times x squared. That would make the x squared term disappear, and then my highest power would just be the first power, so that would be called a linear function. So to be a quadratic function, it has to have this a that's not equal to 0 in front of an x squared. If I graph a quadratic function, the graph's always going to be this shape called a parabola, and we've sometimes seen those before. This value of a that's in front of the x squared, it turns out, we're going to see a little bit later in some examples, that determines whether the parabola opens up or down. If a is greater than 0, then it's going to open upward in this way. A parabola always has an axis of symmetry that goes right through the middle, and a top or a bottom point that's called the vertex. And so we will look for those special points in this line of symmetry when we're graphing these most of the time. Also, if I do that process of completing the square, which we were using to solve quadratic equations, we can turn any function that looks like this up here, ax squared plus bx plus c, we can turn it into something that looks like this. It's called standard form. The a is still there, but now I don't have just x squared, I have x minus h. It could be a plus, it's whether the h is positive or negative. We've got x and another number squared inside parentheses, and then I've got another number plus k at the end. So I'm just going to do a few examples where we have different values of either a or h or k, and just see what do those letters do. So let's say we're graphing y equals x squared plus k. So let's graph these functions. We're just going to do some point plotting. The first one, if I've got y equals x squared, I'm just going to pick some typical values for x. You could pick other numbers for x, but these are pretty basic ones. So negative 2 squared is going to be 4. Negative 1 squared is going to be 1. Negative 1 times negative 1. 0 squared, of course, is 0. 1 squared is 1. And 2 squared is 4. So I got my x coordinates and my y coordinates, and I can plot these points. So I've got negative 2, 4, I go 2 to the left and 4 up, that's there. We've got negative 1, 1, that would be there. 0, 0 is, here at the origin. We've got 1, 1, and we've got 2, 4. All right, so my parabola is going to go down through these points and curve at the bottom, and then come back up. I've almost got mine going too much up and down here at the end. The parabola should always keep opening outward no matter how far up you go, because I could put in x equals 10 and I'd get y equals 100. That would be way up, beyond the screen somewhere here, but I could do that. Let's do y equals x squared plus 3, and let's do a different color. I'm going to take the same x coordinates, negative 2, negative 1, 0, 1, and 2. So negative 2 squared plus 3, that would be 4 plus 3, which is 7. And then negative 1 squared plus 3, that would be 1 plus 3, which is 4. 0 squared plus 3 would be 0 plus 3, which is 3. 1 squared plus 3 would be 1 plus 3, which is 4 again. And 2 squared plus 3 would be 4 plus 3, which is 7. So negative 2, but I have to count up 7. 1, 2, 3, 4, 5, 6, 7 is up here. Negative 1, I have to count up 4. 1, 2, 3, 4, which is here. 0, 3. We've got 1, 4. And we've got 2, 7, which my black graph is on, and it shouldn't have been. Okay. All right, and now this other one, y equals x squared minus 4. So negative 2, negative 1, 0, 1, and 2. So negative 2 squared minus 4, that's going to be 4 minus 4, which is 0. Negative 1 squared minus 4 will be 1 minus 4, which is negative 3. 0 squared minus 4 is 0 minus 4, which would be negative 4. 1 squared minus 4 is 1 minus 4, which is negative 3, and 2 squared minus 4 is 4 minus 4, which is 0. So I plot those points, negative 2, 0, negative 1, negative 3, 0, negative 4, 1, negative 3, and 2, 0. So I've got these three graphs. I've got the black y equals x squared right in the middle here, starting at 0, 0. The blue graph, y equals x squared plus 3, essentially it got all these same y coordinates from before, right? My y equals x squared graph, the y coordinates were 4, 1, 0, 1, 4. If I look here in the middle of these blue calculations, I see the 4, 1, 0, 1, 4, and then they all just got 3 added to that. That just took all the y coordinates on the black graph and added 3 to them. So the whole graph just slid up 3 units. For the red graph, look in the middle of that, 4, 1, 0, 1, 4. The same basic y coordinates from the black graph, but then I subtracted 4 from all of them. That slid the graph down. So what does k do? K is greater than 0. It moves up k units. And if k is less than 0, the graph moves down k units. So, x squared plus 3, since that's positive, it moved up. X squared minus 4, since that was negative, it moved down. All right, what if I have these different values of a? So, again, if I start just y equals x squared, well, I'm just going to square these values. I get these usual y coordinates, 4, 1, 0, 1, 4. And so my graph looks like that. That's my usual sort of garden variety parabola. If I have y equals 2x squared, well, then I'm going to get 2 times negative 2 squared. Remember, the squaring has to happen for the multiplication, so this will be 2 times 4, which will be 8. If I put in the negative 1 squared is 1, so I get 2 times 1 is 2. If I plug in 0, well, 0 squared is 0. And the same sort of stuff happens when I plug in the positive coordinates here for x. We've got this symmetry. Parabolas always have symmetry. So I've got negative 2, 8, so that's all the way up here. Then I've got negative 1, 2. I've still got, why is it? I've still got 0, 0. Got 1, 2, that would be here, and then 2, 8 up here. This parabola is narrower. Or we could think of it, it's going up faster than the black graph, right? In fact, it's going up twice as fast. And sometimes what you can imagine doing, it's sort of like taking the graph and pulling it up, right, from the black graph in that way. Sort of messy there, but it's sort of like the graph's been stretched up vertically. And if I do y equals negative 2x squared, be careful with the signs here. We do the squaring first, so negative 2 squared is negative 2 times negative 2, that would be positive 4, times another negative 2 on the outside would give me negative 8. Oh, let me write that out. So it was negative 2 times 4, so that's negative 8. If I plug in negative 1 times negative 1 is positive 1, but then negative 2 times positive 1 is negative 2. Anything times 0 is 0. And we get similar sort of results here. 2 squared is 4, so when I multiply I get negative 8. Notice this graph is really the same as the blue graph, it's just been turned upside down because of that negative. Right, the red graph and the blue graph are essentially the same, they're just mirror images like reflected around this x-axis, right? Where the blue graph goes up, the red graph goes down, but they go up and down the same amount. I go over 1 and up 2, over 1 and down 2, over 2 and up 8, over 2 and down 8. So what does A do? Well, it has two things. So first of all, if A is not equal to 1, it stretches, or it could shrink stretches or shrinks the graph, and we say it's doing that vertically. Okay, it could shrink if here I did 2x squared. If I would have done something like a half x squared or 1/3 x squared, it would have taken these original y coordinates and multiplied not by 2 but by a half or a third, and all the y coordinates would have gotten smaller than the black graph. So it would have been a shorter parabola, like a wider parabola. The blue graph was narrower. The other thing we see here is if A is less than 0, it opens down. Of course, then if A is greater than 0, it opens up. All right, so what about this value h? So we've got y equals x squared. That's my basic graph. We're getting sort of bored with this, hopefully. Right, these are really easy to do now. So that's my basic parabola. So that's y equals x squared. Now, if I do x minus 2 quantity squared, I'm going to have to subtract before I square. So I'm going to get negative 2 minus 2 squared. That's going to give me minus 4 squared, which is going to be 16, which is way too big. So let's think about this. I don't want to graph that, right? So when I've got this thing inside the parentheses, I have to be a little bit more careful in how I do this graphing. Let me get rid of all of this here. All right. So, if we look back here, where was this vertex? This vertex was at the point 0, 0. That's when I got 0 out. Can we imagine what would have to happen to this graph? What would I have to put in for x to get 0 out? Right? What would I have to put in for x here to make x minus 2 equal to 0? Well, I think if you think about it a little bit, it's going to be 2, right? If I plug in 2 for x, I get 2 minus 2 squared. That's going to be 0 squared, which is going to be 0. Well, let's put in values a little bit less than 2 and a little bit bigger than 2. So if I go 1 less than 2, that would be 1. Another 1 less would be 0. 0, 1, 2. Then I'd plug in maybe 3 and 4. Let's just see what happens. So 0 minus 2 squared. 0 minus 2 would be negative 2. Negative 2 squared is 4. 1 minus 2 squared would be negative 1 squared, which would be 1. 3 minus 2 squared would be 1 squared, which is 1. And 4 minus 2 squared would be 2 squared, which is 4. So I've got 0, 4. I've got 1, 1. That's actually the same point. I've got 2, 0. That would over 2 up 0. I've got 3, 1. And I've got over 4 up 4. What's happened to those blue points? I still get a parabola through them. But the whole parabola has just shifted to the right. I went from a vertex of 0, 0 to a vertex of 2, 0. All right, well, can we imagine how might I approach this then for x plus 3 squared? Well, we thought here this vertex was when y is equal to 0. What would I have to put in for x here to get a 0 out? Well, I think it would have to be negative 3. If I plug negative 3 in for x, I get negative 3 plus 3 squared. That's just going to be 0 squared, which is 0. So what's less than negative 3? So negative 3, 0 would be over here, right? So what's less than that? I would have to go 1 over, get negative 4, and then negative 5. So negative 5 plus 3 squared. Negative 5 plus 3 is negative 2, and negative 2 squared is 4. When I plug in negative 4, I get negative 1 squared. Negative 1 times negative 1 is 1. So that's this negative 5, 4, negative 4, 1. I'm going to go the other way then from negative 3. I'm going to put in negative 2 and negative 1. So negative 2 plus 3 squared, that's going to be 1 squared. And negative 1 plus 3 squared is going to be 2 squared. So I get that same pattern. So negative 2, 1, and negative 1, 4. So what does h do? So it moves the whole parabola left or right, and it's the opposite of what you would expect, right? So x minus 2 squared goes right 2, and x plus 3 quantity squared goes left 3. So it's sort of the opposite of what you might ordinarily expect. All right, so in general, I have this all combined, a times x minus h quantity squared plus k. We can sort of go through these kinds of steps. We can determine just if it opens upward or downward by looking at this value of a. Greater than 0 is up, less than 0 is down. The vertex we get from hk. Now, how I sometimes think of that, to get the vertex, I think, what would I have to put in for x here to make this 0? Well, since I have to subtract h, I'm going to want to let x equal h. So that's my x coordinate. What happens if I plug h in? H minus h is 0, 0 squared is 0, a times 0 is 0, I just get y equals k. So I have the opposite of this number for my x coordinate, and whatever the number is at the end, that's my y coordinate. I can then plot this vertex, and I always draw the axis of symmetry that goes up and down. Then we can pick two x coordinates on the same side of that axis. I usually go to the left. I usually go to the right. We'll see in the example why I do that. We substitute those x coordinates into the function to get the y coordinates. We then plot those 2 points. They should be on the same side of the axis. Then I can use symmetry to plot 2 points on the other side, right? These have all had symmetry around that vertex. And then I connect the points with a smooth curve, sort of shaped like a bowl or an inverted bowl, right? An right side up bowl or an upside down bowl. The graph should not have any sharp corners, so the vertex is not a sharp point. It's still a curve at the vertex. And it should always curve outward and then either upward or downward. So it never goes straight up and down. It should always still be going a little bit outward. So how would I graph this function? Well, I see here that in front of the parentheses, a is 1. That means a is greater than 0, so it's going to open up. We're going to figure that out anyway. The vertex, I look at this, and the x-coordinate is always the opposite of what's here. So the x-coordinate would be -2. And then the y-coordinate is just going to be this number at the end. Y, -2 plus 2 is 0. 0 squared is 0. 0 minus 5 is -5. So I've got my vertex. I know then that it's going to go through the point -2, -5. So -2, 1, 2, 3, 4, 5. That's going to be my vertex right there. I also have an axis of symmetry, and that's going to go up and down through that vertex. Okay. Then I'm going to pick two x coordinates on the same side of the axis of symmetry. So my axis of symmetry is here. I've got x is -2. I always go to the right. I'm going to pick -1 and 0. And just plug those in. So I'm going to get -1 plus 2 quantity squared minus 5. So -1 plus 2, that's going to be 1 squared minus 5. So that's going to be 1 minus 5, which is going to be -4. So I got the point -1, -4. That's down here. So I went 1 to the right of the axis. Now I go 2 to the right. So I went from -2 to -1. Now I'm going to go to 0. That's what I've got here. So I plug 0 in. So we get 0, plus 2 quantity squared minus 5. That's going to be 2 squared minus 5. That's going to be 4 minus 5, which is negative 1. So I plug in 0 and I get negative 1. So I've got those points so far. So I've found the vertex, I plotted the vertex, I drew the axis of symmetry, I picked two x coordinates, I substituted into the function, and I've plotted those 2 points, and they are on the same side of the axis, the right side. Now use symmetry to get 2 points on the other side. This point is 1 to the right of the axis. This point is 2 to the right. There must also be points then that correspond to those on the left side. So I start at the axis and I go 1 to the left, and then I start at the axis and I go 2 to the left. And there's my familiar parabola shape. I just connect those points, make it curved at the bottom, make sure it keeps moving outward and upward, and there would be the parabola. One thing we're going to see, we'll have one example problem like this. If I switch sort of the y and the x, so instead of having y is a times x minus h squared, if I have the x first and have y inside, we graph it very much the same way. It's just important though that here, if you realize whatever number you're putting in there, you're putting in for y. So now this would be the y coordinate of the vertex and this would be the x coordinate.